Good day everyone, welcome to my video. This video is entitled Full Factorial. Okay, what is full factorial? So full factorial is a screening method. Now we have talked about over one way which we have one factor and over two which we have two factors. What happens if you have more than two factors? It's going to be very hassle to calculate and over 3 ways, 4 ways and 5 ways using hand. You can use it special software like Design Expert, SSPS from IBM. But because of we are dealing with exams and you must calculate with hand, so I'm teaching you now full factorial. Right, full factorial is based on 2k. Right, so previously you have one factor with many levels. However, for this full factorial, this 2 belongs to level and this k belongs to factor. That means you can have many factors but only 2 levels. One is low, one is high. Okay, so we call it as shortcut because we can definitely find which one is the main factor, number one, which one is contributing the main factor, main interaction, and last one, we want to see if the experiment happens or not in the factors or interaction happens or not in the experiment based on the full factorial calculation. Fortunately, we don't have to find any H naught or H alternative in full factorial because the calculation itself will just show you which one is contributing. Okay, so you must have low and high. So let's increase this to 2 point, low and high. One more point, low and high. So either you have temperature, let's say time, maybe 10 seconds to 20 seconds. Temperature, maybe 20 degrees Celsius to 40 degrees Celsius. That means you have two different levels, just two maximum, right? People, between a friend and another friend, between boys and between girls, only one boy and one girl. Between marks, between classes, only two levels, right? But many factors. And this is very widely used in the industry. Widely used in the industry because it's a shortcut way to understand the experiment. Okay, you need to be introduced with Yates order. Sorry, where is it? Let me go back. All right, you need to be introduced with, oh, that's why, with Yates order. Yates order is this one, right? So that means the order of the experiment is done by, the first experiment is coded, right? Coded, I write here coded as the first experiment, second experiment, third experiment, fourth experiment, and so on and so forth. You'll have more than this, right? And the order of contrast, which is the high and low, is given by signs. This one stands for low, this one stands for high. Some textbooks use the word low itself, low, high. This one I'm using negative and positive. Some use 0 and 1. Some will use 1 and 2. Any depiction of low and high, you can use it. But to make it standardized, whenever you see my notes, it is minus and plus, low level and high level. Okay? Okay, this is the Yates order and the codes. This is the contrast, right? Contrast. For A, if you want to find for factor A, you must code and use this. -1, A is positive, B is negative, and AB is positive. If you plus all these sign, minus plus positive plus minus plus positive, it will be 0. This will be 0, this will be 0 as well. So Yates order geniusly assume that all H0 accept. Right? But again, in this case, we don't really have to consider about H0. His calculation already make this H0 except the first assumption. Alright, in the final exam, you'll be given this. This is a 2 power of 4. That means you have 2 levels and 4 factors. 2 power of 4 equals to 16 runs. Right, 16 runs, right? 16 runs. Anyway, 16 runs. So it is coded by 1 bracket 1 A B A B C A C A C A B C D A D B D A B D C D A C D B D A C D C A B C D, right? A B C D. From this section, you can actually extract 2 to the power of 3 and 4. So on the next slide is to the power of 2, right? So 2 to the power of 2 means you have factor A and factor B and interaction AB. You have seen this before, it is ANOVA 2 ways. So full factorial is a shortcut way to do ANOVA 2 ways. Full factorial is the ANOVA calculation, right? So you have AB and AB. So you have this and this. So where did I get this from? So if you go back to this slide, you can see it is taken from this section. 2 and 2. Right. 2 to the power of 3, that means you have A, B, C, and interaction. A, B, A, C, B, C, and the triple interaction A, B, C. You see A, B, A, B, C, A, C, B, C, and A, B, C. 2 to the power of 3 equals to 8 runs. Right? 1, 2, 3, 4, 5, 6, 7, and 8 runs. So where do I get this from? Go back to this slide. As you can see, magically, oh, that's magic. From here to here is 2 to the power of 4, 3. And the rest is 2 to the power of 4. So you can be given 3 factors, 2 factors, or 4 factors, okay? But again, 2 to the power of 2 are rarely asked in the final exam because it's too simple. You can use ANOVA 2 ways. 2 to the power of 3 and 2 to the power of 4 is famous if full factorial question is given. Alright. And again, this is 2 to the power of 4. All of them. 2 to the power of 5. There is 2 to the power of 5? Yes. But I do believe that that's the limit for our class. We just limit at 2 to the power of 4. Okay, if you like to have 2 to the power of 5, go ahead and go read all the statistic books. Okay, so why not we just straight go to the 14th slide to one of the experiments. So I will do 2 to the power of 2 case study, right? And then you have 2 to the power of 3 case study, and you have 2 to the power of 4 case study. We will go one by one, right? One by one, example by example. Okay, so bear with me. It's not that hard. It's quite easy. It's just it'll take a longer time to calculate. Right? It's the 13th slide. Okay, on the 13th slide is 2 to the power of 2. That means you have 2 levels and 2 factors. What are these? So what are the factors A and B? So here is a story or question about a reactant concentration combined with catalyst amount, and we want to see if the levels for A is your reactant concentration, 15% and 25% concentration, and 1 pound and 2 pound of catalyst. Right? So for A concentration and B is a catalyst, you have low and high. Catalyst concentration is 15% and 25%. And level B catalyst, you have 1 pound of catalyst, 2 pound of catalyst. So in this experiment, 2 to the power of 2 equals to 4 runs. 1, 2, 3, 4. How do you do this experiment? You will not be asked in final exam. But if you decide to do it in your final year project, or in any project that is involving full factorial, you can use the first experiment, combine A low and B low. That is, take 15% and 1 pound of catalyst and concentration, you combine them, do the experiment, you get the time. Let's say the replicates is in second, right? So the first experiment you do, you get 28 seconds. We must have this notion that we must duplicate or replicate our experiment so that we have diverge amount or maybe a bigger range of data. In this case, you can see that we replicate this 3 times. Okay, n equals to 3. In the second experiment, you combine low and high. And the third experiment, A low and B high. Second experiment is A high and B low. And the final experiment is A high and B high. You repeat it 3 times. That means 4 experiment times 3, you have 12 runs all together. Okay? Right. So here is the total. This total comes from, this one comes from the addition of these two numbers. Right? This one plus this one equals to this, plus equals to this, plus equals to this, equals this, yeah? All right. Oops. Okay. So this is to find the main factor. To find the main factor, you look at A and B. So technically, you can use this table, right? So A and B. The calculation for A and B is given as such. So let's write this down. Okay. Okay. Write this down. Okay. So you can find factor A and factor B. This is the equation for 2 to the power of 2. Okay. In full factorial calculation, you must have two things. You must have effect estimates, right? Effect estimates and sum of squares, just like ANOVA, right? So effect estimates for 2 to the power of 2, that means you have factor A and factor B. That means you must have effect estimate for A, effect estimate for B, and the interaction. Alright? So whatever in this bracket comes from the table, right? And you have to divide by 2n. For sum of square, whatever you have from that table, you square them and divide by 4n. For 2 to the power of 3 and 4, these numbers increase. I will discuss this later. I don't want you guys to get confused. What is the usage of effect estimate? Right. Effect estimates will give you the positive and negative value. Remember positive and negative? Positive high, positive yield. Negative means a reduction of the yield. It's the same thing. Same thing. Right? Sum of squares will tell you the contribution, just like the H0 and H1. Is it significant? Is it more than 1? Is it less than 1? Is it exist or it doesn't exist? Okay, so that is the usage of sum of squares. Okay, so I take this snapshot from the big 2 to the power of 4 table, yeah? So how do I get these equations? So I'm going to use this blue ink for A, for factor A, which is this one. For factor A, you can see is 1 divided by 2n. This is a must for 2 to the power of 3. And you can see here AB is positive, A is positive, negative for B, and negative for 1. But if you look at B, AB positive, suddenly B is positive, this is negative, this is positive, this is negative, this is positive, and 1. So the same number but different signs. How do we get this? Easy. It comes from this column. For A, right? So let's bring out that eraser. Let's clean this up again. Right? For A, bracket 1 is coded as negative 1. That's why it's negative. A is positive, B is negative, AB is positive. For B, A is bracket 1 is negative, A is negative, B is positive, AB is positive. For AB, bring out the green pen. Bracket 1 is positive, A is negative, B is negative, and AB is positive. I will not give you this AB plus in this form, yeah? I'll just give you this table. You have to derive the equation yourself. That's the fun part of it. Alright, so you need to replace all these positive, negative into these. You see this one, the one I'm circling now? Into that one. How do we do that? So this one, the replicates the total here is actually coded as such. 1A, B, AB. Right? So 1 belongs to the total of 80, then 100, and B is 60, AB is 90. So if I take A, A 1 over 2n in the bracket, right? So here A bracket 1 is negative. So sorry, bracket 1 is negative. So you get negative 80, positive 100, negative 60 plus 90. Okay, for SSA is 1 over 4n, negative 80 plus 100, negative 60 plus 90 square. For B, B 1 over 2n. For B is negative, negative, positive, positive. Right, negative 80, negative 100, positive 60, positive 90. SSB 1 over 2, 4n. Negative 80, negative 100, 60, 90 squared. AB 1 over 2n, right? The sign is plus minus minus plus. So 80 minus minus plus. SSAB 1 over 4n. 80, 100, 60, 90 plus. Okay, and you get these are effect estimates. And you get these values. Alright, between this two, A is your main factor because it has the largest magnitude. Okay, it's positive. That means you can go as high as you like. B is not your main factor, but it's negative. That means don't go high. The higher you go, the lower the output of this experiment, which is the catalyst or the reaction. Both of them, if you combine a high A and a low B, you get a positive interaction. All of them is more than one. Right? More than one. That means they are in this experiment, exists. Interaction also happen, A and B also contributing to this experiment. Good, very good. And some more, if you use high A and low B, you get a positive interaction. Okay, that is for. And this one is, you can read this. This is how you write in your final exam in this slide. Okay. On the next slide is ANOVA table. That means this is coming from and software. As you can see, with ANOVA also you can choose about 3 or 3 factors. And you can ask the software to come up with just what you like. For example, here you can see that it only asks A, C, and interaction AC. Because AC is the one that really affect the experiment, right? So that's what the best part of the software. We don't have it in our lab, so just pray maybe one day we have one. Okay, you can read it. We go for the final one. That's why I put a love there, because I love you guys. 2 to the power of 4 orthogonal contrast, which gives you 4 factors and 16 all the calculation. And the equation increased from 4n for effect estimates to 8n. Sum of square from 8n becomes 16n. Next, the factorization, yeah? Okay, example, straight ahead. This is an example for filtration rate of a resin, right? It is assumed that A, temperature, B, pressure, C, concentration of formaldehyde, and stirring rate are the factors that affect this experiment. And the filtration rate, gallium per hour, is the one that we are looking for. And you can see there are no replicates. I'm going to write here, no reps. Therefore, N equals to 1. And it's already coded A, B, bracket 1 to all this, right? For your easy calculation. Okay, assuming that you're going to calculate this in exams, I'll just take one, yeah? Maybe I am going to do E, A in a bracket. So, I believe we begin with minus, plus until there. So easy to do. So, bracket 1 is minus. So, negative 45. And then, I'm going to use another iPad of mine. And then, positive 71, negative 48, positive 65, negative 68, positive 60, blah blah blah. And the final is 70 it should be negative 70 and plus 90. All of this divided by 4 times 1. Alright, therefore your sum of square for A, just copy it, 45, 71, 48, 65, 68, 60, 70, 90 square divided by, oh, it's not 4n anymore. It's my bad, it's 8n. Yes, sharp eye, guys. Sharp eyes. 8n and 16n. Right? And if you fulfill and finish all 32 calculation, congratulations. And you'll get this value. Alright, let's talk about this. You see here A, B, C, D. Which one is your main factor? The biggest contributor, 32%, which is the what is it again? The temperature. The higher the temperature, the higher the filtration of resin. Good. And then you can see this is more than 1, less than 1, more than 1, more than 1. What is less than 1? It's pressure. So pressure is less than 1. It's less likely pressure is going to affect this experiment. Looking at the effect estimate, all of them, 4 of them have positive value. That means you can go high as you like, individually, right? Take a look at the dual interaction. You can see that AC is the main interaction followed by A and D. So temperature and concentration of formaldehyde and temperature and stirring rate is your main interactions. And also, you can see that they are positive. That means you can increase the temperature as high as you like. You can increase the stirring rate and concentration of formaldehyde. It will help with the filtration of resin, right? And the rest, this one happened, not happening, not happening, not happening, not happening. Good. If you want to know more about this combination, you can bring it out and do ANOVA 2 ways. Right. In each combination triple interaction. If you are interested in triple interaction, right? So ABD will give you a more than 1, less than 1, less than 1, less than 1. ABD has a positive effect estimates as well as it happens in the experiment. If you go take a look at this, BD has negative values. That means B and D, if you combine them, it will give a negative output. However, it is less likely to happen. So we don't have to worry about them. Okay? You don't have to worry about them. And finally, A, B, C, D have a less than 1. That means if you're interested in the total, everyone is going to contribute, it is not as likely. So A, B, C, D, even though it's inside this same experiment, Actually, they're just trying to have clicks with one another, not everyone, yeah? Okay, so from here, you know which one is the main factor, which one is the main interaction. Do you like to do extra calculation or extra experiment? Then full factorial can really help you in screening factors and interaction. I can also give you this example of as normal assumption plot. Yes, of course. You can use normal assumption. This one I'll do in another video. Normal assumption plot. And that concludes our full factorial lecture. So I'll be seeing you in another